In lesson 7 on page 59, you will be computing or calculating with scientific notation. So I'm going to tell you the rules, but please remember, if you have no letters, so there are no variables here, no x's or y's or anything, you can use the calculator for this type of problem. So in the calculator, I can type this number plus this number and press equals to get this number. Okay, so make sure that you're checking your work at least in the calculator. But let's go to our guided practice here. When we're multiplying with any exponents, remember that we would add the exponents. Because my base here is 10, I can add the 5 and the 2 to get 7. The numbers will act just like regular numbers. So if I do 2.6 multiplied by 1.9, I'm going to end up with 4.94, and then I would write times 10 to the 5 plus 2 is 7. And that would be my final answer on this one. It's the same thing on this, except because there's a bar, this means division. Remember division. This one is multiplication because there's parentheses, and parentheses mean multiplication. So division here, I'm going to divide the two numbers. And when I divide these two numbers, I get 3.1 and subtract the exponents. Remember our exponent rules. When we divide, we subtract the exponents. So 8 minus 3 gives me an exponent of 5. So times 10 to the 5th power. So 3.1 times 10 to the 5th power is my answer. On number 3, this is a word problem, but your process is the same. So it says in 2005, 8.1 times 10 to the 10 text messages were sent in the United States. In 2010, the number of annual text messages had risen or gone up to this really big number. About how many times as great was the number of text messages in 2010 than in 2005? So easily what I can do is I can change this to scientific notation. Remember, I'm moving my decimal place, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 1.81 times 10 to the 12th power. So in 2010, it was this number. And in 2005, it was this number. And I want to know how many times bigger that is. So here again, I'm going to divide the bigger number divided by the other number. So 1.8, let's do it over here. So 1.8 times 10 to the 12th divided by 8.1 times 10 to the 10th would give me 2.2 times 10 to the 1st power, or if I change that to non-scientific notation by moving the decimal place over 1, it's about 22 times more in 2010. And again, I can use my calculator on this type of problem. So if there's a word problem, absolutely use your calculator. And the way that I knew how to divide is it says about how many times as great. So my key here is as great. How many times as great? This means I'm going to be dividing because we want times as great instead of what amount as great, or what amount bigger, or what amount smaller. So when it says times as great, or times as small, or times smaller, these are division. All right, so when you're adding and subtracting, it's a little bit different. Again, you have a calculator, so definitely check your answers in the calculator. But so here's how we're going to do these type. When we're adding, remember we have to have like bases, kind of, is what we're trying to do here. So one of these has a 9 and one of them has a 6. We want to get both of them to be the same. So you can either change both of them to 9 or both of them to 6. I usually change both of them to the smaller number. So because 6 is a smaller exponent, I'm going to make them both times 10 to the 6th power. Okay? From 9 to 6 is 3, and it's 3 smaller, so I'm going to move my decimal place 3 to the right. Okay, so when I move it 3 to the right, I get 8,900 times 10 to the 6th power. So now they're both times 10 to the 6th power, and I'm going to add the numbers. So 8,900 plus 4.2, and so I would get 8,904.2 times 10 to the 6th. So the times 10 to the 6th does not change. Now, when I write my final answer, though, I want it to be back in regular scientific notation. So even though this is technically a correct answer, I'm going to go ahead and change it back to normal with a number and then the decimal. So my decimal right now is here. I'm going to move it 1, 2, 3 places over and add 3 to my exponent. So I'm back at 8.9042 times 10 to the 9th power. Your subtraction is the same type, except instead of it adding at this step, I'm going to subtract. So here, there's an 8 exponent and a 6 exponent. I'm going to change them both to 6 because it's smaller. So there's 2 away here, and I'm making it smaller. So I'm going to go 2 to the right and make it 964 times 10 to the 6th power. I'm going to subtract 964 minus 5.29, and I would get 958.71. Again, I'm going to change that back to regular scientific notation by moving my decimal place over 2, because from 6 to 8, I would move it over 2. So 9.59 times 10 to the 8th power would be my final answer. And you can probably put this into your calculator and press equals, and it will actually give you this answer as well. So if you forget how to change it back to the standard scientific notation, go ahead and put your answer into the calculator and just check your work. Do not answer anything without checking your work in the calculator if you're allowed to check it on the calculator, which I think that you are for every problem. So please, please don't get wrong answers because you're too lazy to put it in the calculator. Don't do that. Check your work. Okay, 6 and 7 are the same type. This one is subtraction, this one is addition. So here, when we change it so that they're the same exponent, this one, if I changed it to scientific notation, would be 1.17 times 10 to the 5th power. So I have 1 to the 5th and 1 to the 6th. I changed them both to the 5th. And then I subtracted the numbers in front, changed it back to regular scientific notation. So I got 1.23 times 10 to the 6th power. And then same thing on number 7. I made this into scientific notation first. It was times 10 to the 3rd power. I changed this one to the 3rd power by moving it over 2 decimal places. And then on my answer, I moved it back to standard form and got 6.85 times 10 to the 5th power. So go ahead and practice those on page 63. We did do a lot of those in class, but maybe not so much the top ones. So check and make sure that you know how to do those, especially multiplying and dividing. Those are easier, and be able to do them in the calculator as well.